All right. First of all, just want to say, can you all hear me? Fine, perfect. Good, cool. So today's talk is going to be on vector database, the what, the why, and the how. I think when it comes to vector database, it's important for us to get to have a feel of what they are. So at the end of this presentation, I'm hoping that you have a good understanding of what vector database are, how do you differentiate them from vector search, and just be more mindful and knowledgeable about the topic. So before we get into the actual presentation, I would like to first start off by introducing myself. I'm Rene Essomba. Actually, I was born in Africa, Cameroon. I've been in Australia since 2015, working at Civil as a data consultant, mostly doing data engineering work. But my background from an academic standpoint has been in mathematics, statistics, and actuarial science. Funny enough, I almost became an actuary, but just didn't work. Through that, got good exposure to a whole bunch of industries, mostly insurance, banking, and then later on started doing a bit more work in other space, like retail and HR. Another thing that I do enjoy outside of like engineering work and coding is basically like outdoor activities and CrossFit. I do actually compete in CrossFit competition, so I can call myself an athlete, but not an elite athlete, but you know what I mean. So cool, let's just move on. This is a QR code. Please scan the QR code, ask your questions. It will take you to your Slido. Ask your questions. I know not everyone will have a chance to ask a question during this session. I only have half an hour, but please use that to be able to, ask your questions. And perhaps like if there's anything you want to follow up, just enter your email. Very optional, but you can do that. So I'll just leave it on for another 10 seconds before I move on to the actual presentation. All good? All right, so when we talk about attention is all you need, does that ring a bell? Any people here, attention is all you need? Show of hands, if that rings a bell to you. Yeah, a few people, I guess the data scientists in the house. For those who doesn't know what attention is all you need, means it's actually a paper that was released back in 2017, and essentially it introduced the neural network architecture that leveraged self-attention, right? And essentially, what you see is that it started doing well with any task from like natural language understanding and chatbots and so on. And you can actually see that was actually like sort of like the grandfather of all the ChatGPT stuff that we're seeing these days. So fast forward to 2023, so this year, we can see that these models actually do require some memory, be able to understand, be able to remember conversations, and be able to pick up the right knowledge in terms of answering your questions. And that's where I think, as you probably with this presentation today, is going to be on vector database. And all you need is not only attention, it's also memory and storage. So that's, I think, is a good segue into this presentation. So from an agenda perspective, we want to talk about LLMs, which are essentially why we want to use vector database in the first place. I mean, why vector database became more relevant, even though they can be used for other use cases. We'll talk about the what, the how, the why, and then we'll dive into the understanding how you get to choose the right vector database, and maybe if we get a bit of time, we'll go through a Q&A session. Cool. So LLMs, or large language models. So when ChatGPT became quite prominent and got mainstream, we already knew that all these beautiful self-attention models that were created were actually being utilized for tasks like question answering, sentiment analysis, text summarization, machine translation. But with the LLMs, it became even more relevant. And we've seen, a lot of like use cases being created, companies and startups that are actually being built on the back of these LLMs that essentially catered for these kind of needs. And it's actually been quite interesting to see how people have been adopting this technology quite quickly. However, when you talk about LLMs, we do see that they do have a few challenges. So one of them, as you may know, is hallucination, which is essentially a scenario when your LLM starts fabricating information. And as the way, it's actually been trained and the way they operate is just sequence of words that kind of make sense. So when it starts answering these questions without necessarily having the right source of information, that's what we call hallucination. Another challenge that LLMs do face is they tend to be being trained on large corpus of data. So we don't necessarily give them specific knowledge about a topic. It's just, a large corpus. So we can sort of see them as like a jack of all trade, master of none kind of scenario. Also, lack of explainability. Most of the time you get answers, but you don't get to see where it got the information from. So, and usually how you overcome this kind of challenge, you have literally two different kind of situations. They're probably a bit more or maybe like a combination of these two, but fine-tuning is one of them. And then you have vector database on the other side. So fine-tuning it's been very similar to what you know from a deep learning perspective called transfer learning. Essentially what it does is you just fine-tune your LLMs, which was trained on a large corpus of data to be more specific about the use cases that you want to train on. The challenge with fine-tuning is that you can't somehow still overcome the challenge of hallucination. It's still probably going to be quite relevant. Another challenge that you see is that hosting those LLM models are quite a big, you probably will require quite a few compute power. As you know, these models are pretty large, 60 billion, 64 billion parameters, and you have to run that on CPU. Good luck with that. And also, it's quite difficult to sort of manage accessibility to those models. And that's where vector database kind of shine, because it gives you all this flexibility. And you don't necessarily need to work with a fine-tuned model. You can just grab any model. But obviously, that is more appropriate for your use case. Back it up with a vector database, and it sort of open the door to sort of thinking about stuff like running your private ChatGPT, which I think a lot of organizations out there are looking to build. So now we're going to dive into a vector database. We're going to take a little detour. A very special type of database for LLM engineers. And yeah, let's see how it goes. So now we're diving into the what, so understanding what vector database are. But before we get into this specific topic of vector database, let's get a feel of those entities that you actually get to store in your vector database. And they're essentially being called vectors or embeddings. So just to give you, a sense of what an embedding is, if you look at, what we have on the slide here, you have literally 4 images, 4 different superstars. Stephen Curry, LeBron James, Bruno Mars, and Kendrick Lamar. So without even thinking about the embedding process, you know for a fact that when you're looking at these 4, you can already group them into 2 blocks. So on one side, you have the basketball players, and on the other side, you have the singers. So what you expect is your embedding to be able to capture that information, and when you actually project those 2 entities convert them into vectors and project them into a space, you want to see that your understanding of what you see from these images is actually being captured with the embeddings. So embeddings essentially encode the information that it extracts from any entity, and as a vector provides you with like a whole bunch of numbers that don't necessarily make sense. You don't need to try to decipher what they mean. But when you have those vectors, what you would expect is in your vector space is actually going to show you what exactly you understood by looking at those images or text or whatever. So embeddings can be created for literally anything you can think of: documents, images, and audio. And essentially, once you have created those embeddings, you can essentially now store them in your vector database. And from there, there's going to be similarity search that you can apply on top of it. Another thing that is worth mentioning is that when you create those embeddings, you can also have, in the encoding process, the metadata that is being carried with that information. So if you have a document that is, say for instance, two documents, one is 2019 and the other one is 2017, those dates, publication dates, can be carried into your embeddings. So that means when you actually perform the similarity search within your vector database, you can actually do filter based on the metadata that is being captured. So publication date could be a way to filter the information that you want to be surfaced to you. So that's in a nutshell what you would expect from a vector database. Some of the key characteristics of the vector database, especially if you want to try to compare them to your traditional NoSQL database, number one, you have the data representation. That is essentially when you compare that to, traditional NoSQL database. The traditional NoSQL database will use key value pairs, documentation-wide column structures, whereas vector database essentially use vectors and operates on these vectors to perform mathematical operations to be able to represent them into a vector space. The query approach when it comes to vector database, essentially it's all based on similarity search. So the beauty with vector database is you can perform fuzzy search. You don't need to have specifically the exact structure of your sentence will have to match to something exactly in your vector database. It's all fuzzy matching. And compare that to your traditional SQL database, traditional NoSQL database, you have to, essentially the filter has to be exact match for you to get the outcome you're looking for. From an optimization standpoint, vector database employ approximate nearest neighbor, and essentially that's how you can optimize your search query. The beauty of these vector databases is you have a whole bunch of access to multiple algorithms that helps you to optimize your query. So you can use all kind of method, and that's encoded into the vector database that you're using for your use case. Cool. So now that we've got a understanding of what they are, so I think let's just dive a little bit into how they do perform or how they do work. So this diagram essentially is just to show you my understanding, and I think what everyone needs to understand when it comes to vector database, because most of the time you get to see people kind of mixing vector search and vector database. So key difference is the database components of your vector search, which will now be called a vector database. And one of them is CRUD operations. So what does that, in a simple term, what it means is that in your vector database, you can essentially create new vectors. You can delete the vectors in your vector database. You can read them or you can update them. And that's, I think, it's a key functionality that we need to understand about vector database. Some other required capabilities that you want to get from your vector database are things like single level store, which essentially means that the vector database adopts a principle of a single level store, which implies that on-disk representation of your data is mirrored as close as possible to your data. Another point to know about vector database is the indexing mechanisms. Obviously, we spoke about earlier about approximate nearest neighbor, which is a way to encode, a way to perform the search within your database for when you work with your embeddings. Another point is filtering. And I spoke earlier about the metadata being encoded while you encoded in the process of creating the embeddings, and that is actually what you actually could use to perform filtering on your data. Another point is being the vector database do leverage GPUs essentially for fast processing. You can use that. And also cloud native tools such as Kubernetes that helps to partition your individual works units and assign dedicated resources to each one of them. Replication, it's a no-brainer because if we think about what we need from a traditional database is also what you get from a vector database. And then obviously, last but not least, be able to have APIs accessing to the vector database. So you have languages like SQL and Python that you want to be able to use to interact with the vector database. Cool. So now that we've got a good glimpse of what they are and how they work, we've kind of like trying to put it together. Looking at this slide, we can see that vector database essentially allow us to perform operations such as be able to retrieve the information that we're looking for. If you think about this specific use cases, in terms of the pipeline, it's always going to be you have your data sitting, perhaps in your lakehouse, data lake, going through an embedding, and then you store that in your vector database. And then from there, if you want to be able to retrieve the information that you're looking for, you can set the number of results that you want to get out of it. You can apply filtering mechanisms to be able to retrieve the data that you're looking for. So now looking at why you will want to use a vector database and some of the key advantages. I've got 3 points here. There's quite a few that you can think of, but if you kind of want to summarize them into 3 different main points, we can see that vector database can definitely be can be used to handle large amount of data, and especially also large scale data sets, which is quite powerful. Another point with vector database is that we can implement semantic search. And semantic search means that you essentially perform search without necessarily getting the exact match of your search, which is quite powerful. And then beyond just what you can get from your traditional LLMs, vector database can also help you to uncover relationships. So if you remember from the some of the slides on the Bruno Mars and Kendrick Lamar slide, we saw that once we project those vectors into the vector space, we were able to see how close some of them were together. So if you think about, you have multiple vectors, you can actually kind of visualize them into that vector space and be able to see which ones are more connected to the other. So when you look at emerging architectures in that space, not necessarily vector database, but the whole space of LLM ops, you can see that you're always going to have to think about other elements in your system. So caching, orchestration, and all of that. But one of the key elements that we're always seeking to get a proper LLM application running, vector database is one of the key components. But you do have to worry about other things, and that's where, if you think about some of the parallel that we used to have with ML Ops when it first started, the machine learning part is just one tiny box, but then you have to worry about many other things around that. So vector database is part of the list of the things that you need to worry about, and that essentially sets you up for success when it comes to delivering LLM applications to your audience and your clients. In terms of business values, this slide I wanted to just extend a little bit the application of vector database beyond LLMs. Obviously, one of the key use cases that we've seen out there are things like recommendation systems, media retrieval, and natural language processing, understanding, and for anomaly detection. So with vector database, you have a whole bunch of use cases that you can come up with, and I think it's just a matter of be able to see how you can actually best leverage your vector database. So you can have a vector database that is not necessarily just working for your LLM applications, but can work for many other use cases within your organization. So with that, I think with all that information, the next question you want to ask yourself is, how do you get to choose the right vector database? And the problem is, it's a really hard question to answer. Why? Because there's just quite a few providers out there, whether you want to look at from a commercial standpoint or whether you want to look at from a open source standpoint. There's quite a few vector database providers, vector search out there. So I think it just comes down to what is specific to your use case. And funny enough, when I was setting up this slide, right now there's a lot more newcomers in the game. So this slide is probably a little bit outdated, and it's also a testament of how fast this this space is moving. But if you want to start looking into how you want to go about choosing the right vector database, we've come up with a set of questions, 10 questions, quite a long list of them. But essentially, what you want to be able to, and these are could be summarized into a few questions, or you can extend that. But looking at these 10 questions, what you want to be able to see is you want to be able to determine whether your data can be represented as vectors. Also, because that will allow you to understand whether you actually need a vector database. Once you pass that, the second question you want to ask yourself is, you want to look at the dimension of your vectors. That's another point to consider, because the bigger your vectors or the higher dimension it is, the more compute will have to be required for you to perform similarity search. Another point with that you want to be able to understand with vector database is understand how you're going to scale your data. So what is expected, how your data is going to grow over time, and this information will help you to choose perhaps the right vector store that will be helping with the large volume of data coming into your system. Another point, that question number 4, what you want to be able to understand is the indexing techniques and the search method that will have to be performed, because that also, the search method is one of the elements that could either slow down your search query or make it faster. So you have to be able to understand that specific part of the process. In number 5, what you want to be able to understand is the performance of the query. So latency applications is something that you need to consider for your analysis. But you may need to see that whether your vector database will be utilized for real-time or near real-time scenario. In terms of scalability, that's definitely something to consider, because you're going to be facing situations where the more your model or your application is out there, you're going to have definitely like a growing number of customers wanting to hit that specific application. That means it's going to be hitting your vector database quite often. So you want to think about scalability. Another point to consider, like I mentioned in one of the previous slides, the APIs, some of the programming languages that will be interacting with your vector database. Myself, I'm a Python programmer, so anything Python is beautiful. Anything beyond that, it just goes over my head. Actually, let me rephrase that. It doesn't go over my head, but it takes more time to adjust. And we want to be able to make sure that the vector database is not me. It's actually have a much wider access APIs from that standpoint. Also, you want to be able to think about the crude operation that will be performed in your database, deletions, addition of new vectors, and so on. And who's going to support that? And then also, some of the other ones, deployment infrastructure, as you know, that's something that we need to consider. And then obviously, the pricing and licensing. So that's where you want to think about whether you want to go open source or you want to go vendor, and what will be the pricing license model that you want to use for that. Cool. So I don't have an actual use case or a demo to show, but this is something that at Civo we implemented, a really small POC that we kind of like run internally, and it's actually been quite fun to implement that. This is not production ready, so don't grill me on this architecture, but this is just to show you that we can sort of like start building beautiful things, LLMs, whether you want to run them on your on-premise or you want to run them on the cloud. But yeah, this is what we managed to do, and yeah, so feel free to ask questions about that. And with that, I think we're done. So any questions?